Nice to meet you all here today for the workshop of the introduction to the TensorFlow with the application in the sport analytics. And hope you can learn something useful this afternoon. The content for today will be divided into mainly two parts. We will firstly introduce the basic concepts and tools, and then use a simulated example and one real data example to facilitate your gain of the knowledge. And during the presentation, and you are welcome to unmute yourself, and if you have any questions. Let me make sure that all of the attendees are in the panel list. Yeah, let's begin our content today. For the first several pages, I think I could skip them because it's just describe how popular the TensorFlow is and how dominant it is comparing with another deep learning framework. And the next two pages will show what is the tensor and why the tensor learning framework is important in nowadays analytics. The tensor is just the data with dimension. Zero dimension tensor is just the scalar, as we know. The one dimension tensor is the vectors, and two dimension tensor is a matrix, and three dimension you can imagine that will be a cube. And why tensor is so special in the nowadays analytics? Because the vector matrix operations and the gradients, just the derivatives are dominant in machine learning and deep learning framework. For example, the following algorithm you may very familiar with is the gradient descent. It's just an update row, and the beta hat the is related with the old version, old beta hat and new beta hat. And the beta hat just the vector, and also the gradient is also a vector. So it's just an operation among the tensor. And also the GPU structure algorithms can lead to a powerful ability to solve the linear tensor operation. So that is the reason why tensor is so important here. And the next page shows how to install the TensorFlow in Python. And I think I have already posted two videos that can guide you about the installation of the TensorFlow. There are several methods for Anaconda or just through the pipe of Python. And you can verify whether your installation is successful based on these 3 lines of code. So now I assume that all of you has already installed this prerequisite. And so let's begin the most important part of today. Yeah, I think this part is most important, the concept. And there are totally 3 concepts: the operations, the graph, and the session. The operation is just very simple, just like matrix multiplications, matrix add, and others. And the graph is we build graphs which represent the data flow of the computation. And with operation and graph already, then we use session to run and to obtain the result. So I know just talking about this is not clear enough. So I don't know whether you have ever played this game in your childhood, but it's my favorite games. And in this game, the mission is to deliver the waters from the faucet to the target, and you can switch every pieces of the tube, and we use the appropriate operation to connect them, and if the tube is finally completed, and then you can open the faucet and let the waters to get to the target. And just actually to write a TensorFlow script is just very similar with these small games, and each pieces of the tube is just the nodes in the TensorFlow. We can make it constant, make it a constant, a variable, uh, a placeholder, and another kind of thing. And we use the appropriate operations like add, matrix multiplication to connect these nodes, and then to form a graph, this blue circle, a graph. And with all of this settled down, then you can use the TensorFlow.session to open the faucet, and then the water, actually the data will flow in, and then through your established line to the target, and then obtain the result. So this is basically a taste of writing the TensorFlow programming. Yeah. And in fact, the order we described above is the programming strategy for the TensorFlow version 1, TensorFlow V1 for short. You may have feel that it is very strict, right? You should well develop your pipeline and data flow, and then can input all the data in. So this is very strict. So it does not allow you to open the faucet when the passageway is not completed, when it is broken. So by contrast, the TensorFlow V2 version 2, the faucet is opened moment by moment. It means that you can put there one node and make a valid connection between a byte operation, then the water will flow to the end of the tube and stop there. It will not leak. So we use the word eager executions to describe the faucets. It's opening moment by moment. Then you can immediately obtain the data, the result, step by step. So V1 and V2 have their own pros and cons. V1 is good at integrity, but lose at the flexibility. Well, the V2 version 2 is the opposite. So version 1 is frequently used in the final delivery, but the version 2 is good at debugging when you make some error. So in today's workshop, we are focusing on the TensorFlow V1, but I have to mention that V1 and V2 are fortunately compatible now in the package TensorFlow. So the default is version 2, but if you want to use the version 1, we can just say import TensorFlow.compat.v1 as tfv1. Then you can use all the functions and method under the TensorFlow v1. So it's no matter that we use v1 and v2. We can also use this only package TensorFlow, but there's a different way to call them, and we will involve this in our further example. So let's next get into the details. And firstly, we will introduce several possible nodes. Remember that recap that nodes is just play a role like each pieces of the tube in the whole graph. And there are several possible nodes can be selected. Let me show it comparing with our code. By the way, all of the resource today are in my GitHub repo, and I think we have the link in our meetings conference website. And the slides are here in the slides.pdf, and all the code involved is in the code folders, and there is a code. There's a IPY notebook file here named Jupyter/code, and you can obtain all the code here. Yeah. So after the installation of TensorFlow, then you can run this to check the version of the TensorFlow is right. So by default, just as what we said previously, the default version is version 2, and you can also import the version 1 like this. Import TensorFlow.compact v1. And then the first possible node for the graph is the constant. The constant can be either scalar, vector, matrix. It's just a concept which is offset with variable. Variable can be changed in futures, but the constant cannot. So to create a constant, it's easy. You just set as equal to the tf dot constant, and scalars can be just inputted inside of the parentheses. And if you want to create a matrix, and you can just use the double brackets, and each rows in the single bracket, and then it will generate a matrix. And also you may generate a matrix constant like this, and just in one single bracket and with the shape control, and assign is to have 2 columns and 2 rows, then the data will file in each rows by row. Yeah. And actually, if you have already assigned the constant, and then you can try to build a graph, just as what we described about. You have a graph and you put the nodes into the graph. So how to do it? We just said g equal to tf.graph. Tf.graph will just create a new graph, and you said with g dot as default, you mean that now we are focusing on this graph. And in this graph, we add the nodes on that. We add node S, add the node M, and then connect them with the just the multiplications operations. Just then obtain the MMUL. This is our name for it. And after you assign them, then you can call this graph, and you will see that this is a special structure, and it will tell you this is a TensorFlow graph. And then you can run that. Now we have already completed a graph. So we have the big picture here, and then we have 2 nodes on it. Let me say it more clearly. So we build a graph, and only 2 nodes on it, one called M, another called S, and we connect them with the multiplications, and we have now we need to define what kind of thing we want to have for the output. So just define this output. And so we use the TFV1.sessions to form a sessions, and then we told the computer that we want MMUL to be the output. Even though in this case there's no input, there's no such a thing like a faucet, but we also need an output. Yeah, so we set.run can tell the computer that we need MMUL as the output. So let's see the code here. This is what we told about, and we settle down these nodes and settle down the graph, and we call G. It may tell you that this is a TensorFlow framework graph. And then so we create sessions, and we tell that we assign the graph G to be the graph we use, and tell the computer that we want MMUL to be the output, and then run session.run. And you can see that this is the output, right? Because we define the matrix M1, the first row is 1, 2, second row is 3, 4, and we times 2 on that. So this is the output. Yeah. Is there anyone have questions until now? If no, we'll continue. The second possible node is the variable. So variable are used to hold and update the parameters. Just as what we said above, it can be changed further after the creating. So to create a variable is also very easy. We use the tf.variable. Please pay attention to the capitalized here. The capitalized is necessary for computer to detect. And we use the tf.ones to create a matrix, 2 by 2 matrix, and with all the elements as 1. Of course, you can use the same method we showed above, just directly create a matrix. The only difference is here is constant, here is a variable. And also, the next difference is that the variable cannot be directly called or directly used in the graph. You must firstly initialize this variable, because it is a variable, so it needs an initial value of it. So here the initial value is just a 2 by 2 matrix with all the element as 1. So you need the initial value. Here you should just run this line sets.run and run what tfv1 dot global variable initializer to make it come true. So let's see the code for it. And here we define a graph, and in this graph we place a node on it. It is a variable, and it is a 2 by 2 matrix. All the element has 1. And if we run this code, and we create a session, and we use session.run to just tell the computer that we want the output to be directly W, and it will give you an error. Why? Because you can see the error told here. The error told you that the variables was uninitialized. So you need this line sets.run to initialize this, and then you can use this in this graph. And we can once again run this, and it will return you the W you define. So it is a 2 by 2 matrix with all the element as 1. Yeah. And further, just as what we described above, we can assign the variable for with a new value. So this is what the constant cannot do. So how to update the new value? So there is a method dot assign under the variable you define. So w dot assign, and inside of the parentheses, you can give a new value to this variable w. And so let's have a look on that. It will give you, I first print the initial value, and then give the w a new value, w.assign, give it a new w. The new w is a 2 by 2 matrix with all the element as 0. So I once again print this new value. So you can see this is the first one. This is the updated one. Yes. And is there anyone have questions for this widget? If not, we'll first continues to our next nodes, possible nodes. You may notice that even though the variable is more flexible than the constant because it can change, it still needs an initial value, right? But in practice, sometimes the value of a parameter is determined by the actual data. For example, you do the regression, you have the response y, and you have the covariance x, but before the data is coming, you cannot tell indeed the value of the y and x, but you know it will be an y and x. So how can we handle this situation? So we use the placeholder. We use placeholder to tell the computer there is a variable, but I don't tell you right now. I will give you the value when I open the data faucet. So that means in the TensorFlow.session. In the session, I will give you the true value, but now I don't know either, right? So we use because the placeholder is a special node under the TensorFlow version 1, so we use the tfv1 dot placeholder to create a placeholder. TF we assign the node 1 to be a placeholder, tfv1 dot placeholder, and inside the parentheses, the first position tells the TensorFlow what kind of the data type of this placeholder. We tell that, oh, this is a float. And then I tell the computer that the shape of this node is it has one column and two rows. So here I create a node 1, a placeholder 1, and then I create another placeholder, node 2. And then I will. This is very interesting. Just like I draw a picture. So in the first step, I told it that I have a node 1 is, for example, A and B, and I told the computer that there's a node 2, C and D, and then the next thing we will do is to connect these two placeholder, and we tell the computer that we just want it to be firstly the first placeholder times matrix W. The W is what we defined previously. It is a TensorFlow variable with all the elements as one. It's a 2 by 2 matrix, so it's times 1, 1, 1, 1. It is a matrix. And then I told that it's plus the node 2, C and D. And then we name this to be W/linear. So we are in the data flow, we will connect them and output W slash. And then we this graph is created already, and for this graph, because it's a placeholder that right. So it's need us to feed the data in it. So how could we do this? We also use this is similar with previous code. We name the tfe1.session, create a new session and name it as SESS, and sets.run the global initializer. This make us this give us ability to use the W we defined before, and then firstly I just print out the W, and then I print out the outcome here. In this line, I just tell the computer that we want W slash to be the outcome, right? And then because it involves two placeholder, so I use a dictionary here. So this dictionary is created for feeding the data. So we tell the computer that how we feed the data, we use this feed dict to feed it. And the first key is the node 1. The value is the data I just feed in is a numpy vector. I use the np.matrix here, so it's also okay for you to use the np.array, which is a numpy array, and it's a vector for the first number is 1 and the second number is 2. And also I tell the computer that our second node, node 2, to be the value of first position is 1, second position is 2. So the finally it will output the W slash according to this operation. So you can calculate this. This is first is 1 times 1, 1 times 2, which is 3. Uh, and 1 times 1, 1 times 1, 1 times 2, it is also the 3. 3, 3 minus 1, 2. So this is should be the 4, 5, right? So you can have a try here. Let us open this and run the code. So this is actually conduct these operations. And also, just as what we said, the TensorFlow v2 is eager execution, and now we just disable this eager execution to follow the programming style as the TensorFlow v1. And actually, this can be written as the very beginning. I mean, in the above, in the when you just input the TensorFlow, and then you can just do this. But now I just conduct this in this code block. And with the G as the graph as default, and we put the node 1, node 2, and the connect them node 1, node 2 together and in this graph. And with this graph built completely, and we firstly initialize W, and to see the W, and then to feed in the data to see the the W linear. So you can see that this is match our expectation, right? But actually here, it is a point that was well to mention. Remember that we create the W as a variable before, right? Here, we create W as a variable. But you remember that we change the value of W by assign a new matrix for it, right? But this time we run the sets.run W, it still gives us the initial value. This is because we run this line. We run sets.run global initializer. It gives the initial value for W once again overlap the zero matrix we assigned it. So you when you just coding, you may pay attention to these kind of details. And now we have already introduced all three possible nodes for the TensorFlow. That is most common used nodes. And next we will get into the operations. So is there anyone have any questions? If not, we will continue. Nope. Yep. So let's continue. And just as we can say, we can see recap that this game figure. We have already placed the node on the graph. The next step is to make sure that you are use the operation to connect them together to forming a complete data flow. So there are many possible operations you can use. tf.add, just add these two elements together. It is element wise. And if the size of two elements is not matched, then it will be a broadcast. You may know the broadcast in the Python, right? This is a fundamental thing. And you can use the TensorFlow.subtract to do the minus, and also the element-wise product can be implemented by the multiply, and element-wise divided can be directly implemented by the divide, and metric style product can be used can be implemented by the tf.matrix multiplication, and there are three judgments and which can return the Boolean type values, and they are less, greater, or less slash equal. So they are commonly used operations. And certainly you can just write x plus y, but actually you can also write the tf.add x and y. It will return back the same result. Just if you need very strict coding style, you may always use this function type operation. Another kind of thing which is very important is the gradient. Just as what we mentioned about the gradient descent, and another kind of optimization algorithms need the gradient. So how to calculate the gradient? Under the TensorFlow package, there is a function gradient tape. It just create a tape, and in this tape, you can write the formula of the relation between y and x, and then use the tape.gradients. The first position you should put into is the response, and the others places there's a bracket, and in this bracket you put in the covariate, and then it will return you the gradient of the response with the respect of the different covariate separately. Yeah. So let's have a taste of the how to calculating the gradients in the TensorFlow. This is very important if you want to write an algorithm by yourself. Now we want to calculate the gradient of y equal to the square power of x. So how to do it? Firstly, we just define a variable x equal to tf dot variable. The value is 3, and then use the just as what we mentioned, use tf dot gradient tape to create a tape, name it as tape, and then in under this tape you write the formula y equal to the x square power with 2, and then we use the tape dot gradients. First is response y, second because we in this case it's just one covariate. We just input x here, and it will return the gradient. So as we all know, the gradient will be what? Will be 2 times x, right? And then the 2 times x, and then the in this step it will return 2 times the value of x. It is 3, so it will return 6. So let's see whether it's return 6. So also we after the graph is complete, we use tf.session to create a session. We initialize the variable here, and then we return. We tell the computer that our target is this gradient, and then print it out to see. Let's see the result. Okay, it tells us 6. So this is the way to calculate the gradient. When just this example is for the one covariate, right? And when there are 4 covariates, and let's see how to handle it. And the first one, we will firstly we defined four variables, and one constant, and we see that we define x0, x1, x2, and x3, and give it the initial value of it, and we give them a name. The name means that in the following graph, how we call this variable. We call this x0, x1, x2, x3, and then we tell the computer that x1 is the trainable is false. The trainable is false is very maybe a very useful trick for you. If you assign this trainable to be false, and then it will in the following code, then it will not allow you to calculate the gradient of it and even update of it. So it's just to fix it. So it's you can just simply regard it as it can roll back to a constant. Yeah. And with this defined variables, and a constant, we create a tape, and in this tape we write the formula y equal to x squared and plus x1 squared plus x2 squared, and then do the tape dot gradient to calculate the gradient. And we told that we need grade to be the gradient with respect of the x0, and so we use the bracket to represent it. Yeah. And so also we with this well-developed graph, and we set the sessions, and we initialize variables, and we obtain output. So let's have a look. It's 6. Yeah, because you take the derivative with respect of x0, and then it will the only term involved will be the first term, and then it will be the same result with the previous code. Yeah. So this is the contents about the gradient. So is there anyone has question? If no, we will move further.
Can you
Yeah, yeah.
explain the why the trainable equals false is important again?
Yeah. Here I set the trainable to be the false. It means that we can't calculate this gradient with respect of x1 and do the update. So you can simply regard it to be roll back to a constant, because previously it is a variable, and then use the trainable dot equal to false, and then we cannot calculate the it's the derivative of this term, and then just let it to be a fixed value. So if you want to see more information about the usage of this, and you can check the TensorFlow.org and to see the details explanation of it. So you can just search this and see trainable and you may just search the variable. Yeah, and use this tf.variable and then search the trainable. And then you may find the explanation of it along this web page. Yeah. But you to understand it easily, you can just regard it as it can play a role of the constant. Yeah. Is there any question else? If no, we'll move further. Yeah, and for programming language, the another most important thing is the logic. So in Python or R, we have the if else condition. So here we also have the same thing. The core line is just the tf.cond conditions, and in the first position you will give a statement to let the computer make judgment of it whether it is true or false. And then if the tf/statement is true, the first position is true, and then it will run A, and otherwise it will run B. So this is a very simple logic. This is a two elements judgment. So if you want to write a more complicated situation, have more than two, you have three, you have four, and you can use the tf.switch/case. You can use this function, and it will give you a way to do that. But certainly you can try the tf.condition in the tf.condition. So I mean in the position A or position B, and you can give another tf.condition. So it may also make the judgment more complicated and to realize more function. So an example is that we just create a constant t1, constant t2, and define a function f1 to be a t1 plus t2, f2 to be t1 minus t2, and you set result equal to tf dot condition to make judgment t1 smaller than t2. So with this value, so we can obviously see that it is true. So it will run the f1. So it will return you a t1 plus t2. So let's see the code here. This block, and then it will give you three, the t1 plus t2. And also the next logic is while loop. In the while loop, it also needs a judgment in the first positions, and the body in the second position, the variables in the third position. So if the first position judgment is true, then it will run the body until the statement is false. And the variable positions needs a tuples or list include all the TensorFlow variable needed in the body parts. So what does it mean? It means that here, for example, in the body part, you have a variable t1 and t2, and then here you just you should need a parenthesis and just include t1 and t2 here to tell the computer that in the body we need these two variables. So it is very strict, but it is the method how to use it. The T1 is a constant, T2 is a constant as well, and define the body to be a tf dot add T1 minus 1, and then T and then T2, and you define the body like to be a function. This function is just T1 equal to the T1 plus 1, and then return the T1 T2. So the first place is also just input is a condition, so it is T1 smaller than T2. So in this case, obviously it is correct. So it will run this body. So in this body, so we can see that it just update T1 by T1 plus 1. And then so until this condition does not hold true. So the first is 1, 5, the second is the second place is 2, 5, and then 3, 5, 4, 5, 5, 5. Until the 5, 5, then this condition is false, then it will stop and then return the result. So this is more complicated than the if-else statement, but is sometimes useful in the programming. So let's try this. So it will gives you 5, 5. So this is how to use the while loop. So it is not very different with just the directly use R or Python, but you should follow the style of it, the structure of it. Yeah. Is there anyone has question with while? Nope. Nope. Then we will continue for our framework. Yeah. So up to until now, we have already involved all the widget or the operations that is designed for today's, and now we just turn into some example to just just to make sure that you just fully get the idea of it. The example is the simulated example is a linear regression. So we assign the true model to be the y equal to x times the beta. The beta is a vector. The first element is 1, second element is 5 plus epsilon. Epsilon is the residual, which obeys the normal distribution with 0 as mean and 1 as the standard, as the variance. So firstly, we just use the NumPy, the Python NumPy to create the data set, right? So we set the data size to be the 5,000 sample, and then use the numpy.random.normal to generate the multi-normal distributions sample. So the x is a two-dimensional multi-normal random variables, and with y to be the np dot to be the matrix multiplications of x and another matrix. This matrix is the beta matrix here. It is a vector 1 and 5, and then plus the residual term. Residual term is also created by the numpy random.normal. Yeah, so this first block is serve as the data generator. And with all the data ready, now we just want to make just as what I mentioned about. We need a graph. We need a design a graph to represent the data flow, the computation flow of it. So here is a empty graph. And for in this empty graph, so firstly, you should just have an idea that how to calculate the calculate operation you would like to use. So here we use the Newton method, which is updated raw just based on the gradient. You can also call this gradient descent. So it means that we give it initial value. It may be beta. We call it beta 0. We can, and then update it. So how to update it? And then it is about mathematical knowledge. We use the beta equal beta old equal to the beta new equal to the beta old minus and given learning rate times the gradient of loss functions with respect of the beta. So this is all about the math knowledge. So how we write it in the code. So here we give we'll set a variable for the beta. So the beta, this beta just represents the estimation of beta. So we just assign it to be a variable, and with initial value of all the element to be 0, and then we want to calculate the gradient, right? So firstly, we should remember that to calculate the gradient, we should firstly write down the expression of it. So the expression of it is y minus x transpose beta, and do this reduced mean is I mean that I just tell the computer that firstly we calculate the square, and for the squared error we calculate the mean to be the loss. So the loss is just So it's just play a role as we tell the computer our loss is y equal to the loss is equal to the sum of y minus x beta square divided by n. Yeah. So we tell computer losses looks like this. And with the expression of the loss, we use the tap dot gradients. And first position is the response, right? Is y is loss. And the second position is the covariance you need to take derivative with respect of. We take derivative with respect of the beta. So beta is here. And then the gradients will be equal to the beta minus a given learning rate is 0.5 and times this gradient. So this is the grade here is just play a role of new beta. The beta new is equal to beta old minus given learning rate times the gradient. So this is the updated function, the formula. And so with all of the things on the graph, and we run a session. We firstly do the initializer of the variable, and then to tell the computer that this grade, this new beta will be the output. So let's see the result. So if we let the initial value of beta to be 0 and 0, the first iteration will return you the result of approximately 0.8 and 5.1. So actually this is very close to the true value 1 and 5. And actually this is not enough, right? We need to update the beta one time another. This is the iteration. So actually for writing a beautiful code, we need a framework. So you may have already have a use of the scikit-learn, right? In the scikit-learn, the machine learning package for Python, it just have this kind of style. You just call this function to build a model, and then for model, it frequently have a method called feed, and then you can feed in the data x and y, and this model will be trained completely. And then you use the model.predict to give a value to make prediction. So this is actually what kind of tool the product the final product we would like to see. So how to realize it in Python? Frequently we use class function. For example, we define a class named linear regression, and next in the class it should have some initial, right? So / initial / frequently in the class to let you define the initial value. So the self is just you can treat it that all the things related with self will be shareable in this class function. And here you set a initial value of beta to be a TensorFlow variable. I told that this type is float, and we name this variable to be the beta. And then we define in this function we have already defined the variable, and we'll create another function define the loss. Loss is just because here it's also need a self because we need the beta value here. So we need self and we need an x and y, and it will return you that the x minus the y minus x, the matrix multiplication with beta, and then do the sum of square, the mean value of sum of square, and then return the loss. So this function define the loss. Another function defined this coefficient function is not very important. It just let you to finally, you have already trained the model and then you want to obtain the coefficient, then you can call this function. So it is not very it's not very useful. But the core thing is in this fit function. In these fit functions, you need an input x and y, and given a learning rate gamma equal to 0.5. You settle the maximum iteration to be 100, and you defined a gradient tape looks like this. This is what we have previously, and you just call this gradient as dw. Finally, you just use what we previously talked about, for the variable we can assign a new value for it. You can just say this variable beta dot assign, but this function assign slash sub means that beta new equal to beta old subtract this kind of thing. So this is similar. You can just write it in another way, just use the function assign, but it is also okay to write in this way. And we tell that the beta update just subtract this gamma times gradient we calculate above. And then with TensorFlow, create a TensorFlow session. We use session.run. Firstly, give the variable initialize and write a for loop. And in the for loop, we just print the self.beta. So you can see, oh, this is how to reflect that it has already suffering from the iteration. Because we tell computer, this is we want the result of beta. The computer will automatically trace back, okay, you want the beta. So on the big graph, where the beta comes from? Okay, the beta comes from this line. So it will automatically run this line. So in this line it will involve DW. So where the DW come from? Okay, DW come from the calculation of the gradient. So through this graph, it will work through for 100 times because there is a for loop. And then we have already run this loop for 100 times. Then we print the final output self.beta. And then we save this model because we have already trained this, right? We want to save this beta coefficient. So we save this model to be a saver, and saver.save, we name this model to be my model, yes. And actually, this is not very necessary if you don't want to save this. But if you save this, and then it will give you a convenience to obtain the coefficient. So here we just we don't need to train again. We just from the model and then to import this well-trained beta, and then return the beta. So this is just the trick of it, and also the predict function. And with all this function together, and we can just call this model equal to the linear regression. Then it will give you an initial of beta, and then you tell that we use X and Y to train this model, and then it will automatically iteration 100 times, and give you a final estimation 0.99 and 5.01. So it is very close to the true value. And also because we have already designed so many functions in the class, so we can directly call the prediction, and then it will also we can obtain the coefficient directly from the storing models in the meta file. Yeah. So this is basically the how to create such a learning framework for TensorFlow. Just combining the knowledge of Python. Yeah, and the last part is I think we have already made the time limit, but actually I want to mention the real data analysis. The real data is from the betsentiment.com. It is a data with respect of the football match, and there's lots of covariates, home team, away team, and the sentiment score for the home team, away team, and for the players. And the response is a final result. Result is there are three possible value, 1, 2, 3. It means different have different meanings. And then with this kind of thing, you can train a neural network models. And in the neural network model, the codes are also below. Yeah. And also, actually, the first idea is that you need to just you need to train it singly and then pack it up by the class function. So the first several blocks is data preprocessing of our data, and just this in this line create train model actually is the I so-called standalone. It means that it just run this one time, and this block is for the visualization. Yeah, visualization of the performance. And this block is just same style as what we previously had. We package all the function feeds, predicts, get coefficient into one class NN, and we call this. We can directly build a model by this and feed the value in here and obtain the coefficient and make prediction. And we also use this kind of class model, a class type model. And so in here, in this, real data analysis, we use the feed, we use the placeholder because we assign the beta to be a placeholder and then feed it, just as what I mentioned, the x and y. There is x and y, but actually when I design the code, I can't tell you the exact value of it, even the initial value. I don't know, so I will use placeholder. And then we use the fit dictionary to feed in the true value of the x and y, and then the other thing is just similar with what we have in the linear regression. Yeah, so that is basically the contents for today. So if you have a question, you may either ask here or by the email from me. So you can just send me the email and I will reply if you have any related question with it. My email is jun.jin@uconn.edu. So you can email me if you have any further question. Yeah, and all the materials is in the GitHub repos, and there's a department website. There's our data science lab website. Yeah. Thank you. Thank you for listening. Yeah. Yeah. I'll be in this room for